Hello everyone and welcome to this talk titled Knocking on Heaven's Door. Nope, sketch that, Knocking on Cloud's Door, because we'll be talking, all about threat hunting in the cloud, specifically Azure AD, and how you can use a tool called Azula created by me to help you, with your threat hunting operation. I'm Task Manager on Twitter. Let's go. So, quick disclaimer, the opinions expressed in this presentation are solely mine, so not necessarily my employer. And this talk is not sponsored whatsoever by Microsoft, nor is this a product pitch. So this is all pure my experience when I'm using Microsoft Azure AD technology. So let's have some introduction with myself. I'm Task Manager on Twitter, as I mentioned. I'm currently working as a senior consultant in the Big Four consulting firm, performing tasks within their managed detection and response service. So I'm, responsible handling their detection engineering, threat hunting, threat research. On top of that, we need to escalate some of the findings that we do find, and we'll do DFIR. And on top of that, these days automation is everything. So that's also one of my responsibility. I really enjoy being in the community. I'm a contributor for the DFIR report. So if you notice that one, Twitter account that keep posting about, breaches, and then they listed all the TTPs, all the IOCs. So I'm part of the contributor. I'm also a contributor for OECD, which is open source detection community. CDF.id, it's Indonesian cybersecurity where I'm from originally. And Sheridan College, I is a session member. I'm actually wearing their varsity hoodie, and yeah, I also love presenting, as you can see why I'm here presenting, sharing my knowledge with everybody else, and I've presented before in the numerous international conferences also. So outside of work, outside of cybersecurity, I love doing fun and eating good food. So I do enjoy photography, specifically astrophotography and landscape photography. Those are some of my recent techs. I love to do fun stuff, new stuff, ATV, like shootings. I love good food. I do cook, and as I mentioned before, I'm from Indonesia, and we are really common with good food. So if you want to try something new, maybe next restaurant you visit is gonna be Indonesian restaurant. I'm proficient in apparently I'm more proficient in memes compared to minor attack, which is kind of funny, but we'll see how it is going in the next few slides. So who are you exactly? So let's talk about you, right? So you're probably a defender or a red teamer, or just like me, detection engineer who want to build detection. Sometimes you can think, okay, this presentation is pretty good, we use Azure AD, blah blah blah. Maybe your boss think about that and you have to go to this one now. Maybe you just get the the reference, the Guns N' Roses title, or the Azula, which is coming from Avatar: The Last Airbender, Nickelodeon cartoon. Or maybe you just lost, you're not sure what talk to watch, and you just stumble upon this talk. But please stay. I make sure that you'll learn something new. So why are you here today? So this are the topics that we're gonna talk today. I will introduce you to myself, everything else which we already done. I'll introduce you to the Azure AD, so you understand what is Azure AD compared to traditional AD. Regarding the reports, Azure AD reports, which is the logging mechanism of the Azure AD itself, and then let's jump to how can we threat hunt using these reports, and then I'll take you to a quick demo of my tools, Azula, based on Python. All the details will be there. All the features will be there, and lastly we'll go to closing. We'll have some notes, and and then at the end, of course, we'll have some time for question. I'll be in the Discord room, ready to answer all your questions. Looking forward to that. So let's talk about Azure AD. So very likely you're here, you're already familiar with Azure AD, and you just want to improve your security. But I don't want to assume that, so I'm gonna introduce maybe some of you to a new concept called Azure AD. So this is an Active Directory concept that is a little bit different compared to traditional, because Azure AD are now in cloud, so it's not your on-premise old school AD environment. So on top of that, because it's on Azure, Microsoft Azure. It's connected to other Azure services. We are talking about HR systems, IAM, etc. And then they call those stuff now as an apps. So not anymore like like components or like devices. So these are all apps, which is the future for cloud stuff. And yeah, you can actually include a lot of stuff in it. We are talking about mobile devices, computers, of course. Of course, you can include computers, servers, VMs, Kubernetes, like all those fancy new stuff. Yeah, you can do that. You can include apps, of course, because that's the future of it. So we can include a lot of stuff compared to, just Windows operating system devices back on the traditional AD. Another differences will be Azure AD will face internet because that's how cloud works. The question is, will it be less secure or is it even more secure? So we'll answer that question pretty soon. And then there's no more domain groups. You call it your roles, and there's like PIN on top of that. You're not only using password, but now you're using intelligent password. You're using, of course, the MFA, passwordless authentication if you're able to, And then for the authentication options, you get SAML, OpenID, OAuth, Federation, WS, which is completely different than like Kerberos, NTLM, like those stuff on the traditional AD. Microsoft Graph or Azure AD Graph will be used mainly to manage this, Azure AD system. And then external users, now known as guests, instead of normally being called trust on a traditional AD. In terms of first assessment of Azure AD, if you're comparing it with the Windows, so you get Azure AD on the left. On top of that, I also added Office 365 compared to Windows metrics. So you can see there's definitely more techniques, TTPs, tactics even in the Windows metrics. But the question is, is it really reflected? So of course this is oversimplification, but from here we can actually see that Azure AD have less attack factor, we can say. But I had some talk with people from Microsoft, and it's really interesting the way we approach a cloud. We shouldn't approach it like the on premise, but we'll talk about it maybe later in the other occasion. So John Lambert, VP of Mystic Threat Intelligence Center for Microsoft, say defenders think in lists, attacker thinks in graph. As long as this is true, attackers win, which is true. So as the defenders, we need to overhaul the way we think. So we need to think in graph too. So initial access will connect the rest of the tactics with the attackers. So attackers coming from the outside, and then they need to access the system. So from there, if you stop them on the initial access, it will be more important. It will be better to stop them there, and then we can actually worry less on the other part of the matrix. So some attack factors before initial access, after initial access, but I want to highlight the one in red. Non-MFA, legacy users. So this is commonly being brute force. MFA user negligence. Sometimes you have MFA, but the user doesn't really understand what it is, so they just accept random MFA requests. Sounds stupid, but it happens not once, not twice, multiple times on the real world scenario. So real employees doing that. So you get alerts, you get a logging that you don't monitor normally to caught those stuff above. So that's kind of something that you miss. You need to, start paying attention to. Credential stuffing, people get breached and they are using the same credentials with the one in your company. So they are using the same credentials to get into your company. And of course, we've seen quite a lot of pretty high increase in the brute force based attack. Brute force, password spray. One of the presentation from Microsoft person in SANS Blue Team actually mentioned 230% increase in password spray attacks in the last few period of time, which is really high. So we might want to start focusing on that, making sure that we get no user being compromised from that attack. So protection mechanism from Azure AD, we have quite a lot of them, of course. We get, of course, the infamous MFA. We get conditional access policy, which is, of course, you need to adjust it first before you are using it right away. Attack surface reduction, which is pretty neat. So the door, let's call it the door. The door will be available just in time when you need to use it. So every other time, it's not gonna be there, which is pretty cool. Blocking legacy authentication, as I mentioned, legacy authentication often get brute force. If we can stop, people logging in from those legacy authentication application, will be secure for us for sure. You can go passwordless whenever you're ready. A lot of preparation need to be done on that. And then the last three will be the one that we're gonna talk most. Like they get all-in-one security portal and some other security solution that you can use other Microsoft products. Risk detection. So this is like machine learning model called Azure AD Identity Protection Automation that will detect risky sign-ins, risky user, and then on top of that, everything will be recorded in your logs in the reporting, Azure AD reporting. So you get audit logs, whatever change in the system, sign-in logs, everybody coming in, everybody trying to sign in, fail successfully, will be recorded, and the risky user, just based on the risk detection above, it will tell you if this user is actually suspicious or not. So this is a screenshot from the Microsoft. So like Azure AD protection summarized. They got 4 of them already listed down there. Azure AD ML risk detection. We'll talk more about it later. Let's talk about Azure AD reports now and see like what's going on here, right? So what is Azure AD report? So as simple as it's providing you with comprehensive view of all the activities in your environment. So there's different type of reports, such as user flag for risk, because they are performing certain combination of risky activities. Risky sign-in reports, which is obtained from the sign-ins report. They contain majority same information, but on the risky sign-ins you'll have like risk related information. And then we get audit logs to help you with like what happened when a user sign in, what is there any action taken inside. So the beauty of these, all reports are interconnected, so you can connect it, for example, by IP address. You can connect it by the user, like email or principal username they call it, and then you can even connect it to some other external resources or 365 logs. You can actually see once they logged in, you get the IP, and then you correlate the IP with the activity in the 365 logs, and you can say, okay, this user delete certain emails after they logged in. So is this suspicious or not? So it's up to you to decide later. How do you access Azure AD reports? There's several ways. The easiest way, just go to the Azure AD menu and go to the monitoring section, as seen in the screenshot in the slide. You can analyze it using Great API, and then you can play with it on the Sentinel. Another processing instruction is there, or you can actually see the data live. You stream it to your SIEM. You can build detection on top of that. So there's a lot of guide available for Azure AD monitor logs, ArcSight, Splunk, Elastic, by utilizing FileBin. So all the data presented here are using Elastic ODFE, which is the Amazon branch of the Elastic. So 4 different Azure AD reports, as I mentioned before. User flag for risk. Whenever users are deemed risky by the Azure AD machine learning, it will flag it as that. There are additional sources such as threat intel or like leak credentials that will help the machine learning with that. So we're not gonna talk about it too much here. We get I'm gonna jump to the last one, sign-ins. So contain all sign-ins information. Who is signing in? What's the IP? Like from which device? Is it interactive or not? Fail or success? Is it MFA single factor? I will tell you there. So this can be used to track sign-in pattern. You can create statistic. You can create baseline. For example, okay, 50,000 users sign in every month. Suddenly we are seeing less users. Maybe there's some problem, on your Azure AD management user management side. So this actually can help you not only security, but it's even like more to like management monitoring. So risky signing, on top of that, you will have the risky model available for you that will flag, instead of user, it will flag sign-ins. So for example, this sign-in from this IP address from, for example, country Indonesia, you don't have like user Indonesia, you're not supposed to see any of that. And then from there you determine if it's legitimate or not. It could be either real time or offline, so it will take 2 hour to 1 day delay. For medium and high risky sign-ins, it's available for everyone, but for the low one, it's only available for the P2 license, which is the most expensive license for Azure AD. For the audit logs, it's just as simple as like what's going on in your system in terms of management changes performed by users and also admins. So it's just available or for like all licenses. So sign-in logs. So we have important attributes, of course. One thing that we want to see, of course, from there, it is that IP address, which IP address is trying to log into my cloud, domain. And then they get some enriched information like location-wise, countries. I think the new one, they also provide ASN, so like autonomous number. And then from there you can determine if it's malicious or not, or are they supposed to log in from there. Just take with a grain of salt, some of the information might be inaccurate. That's why we as an organization, we actually double check it with additional OSINT resources just to make sure all the information is correct. Application and device information, of course, it will tell you which user agent, which like application is the user trying to access, like from which device, operating system, which is really neat. And then you can see user information such as name, ID, principal name, and the type. And then you'll see error failure. For example, if the user failed to log in, is it because they fail MFA? Is it because they fail, like password? Is it because some other errors? Sometimes you will see error results called others. When that happens, you need to see the code and then you need to look that up in that link I provided, microsoftonline.com/error. And then there's time information, which is really critical here. So the properties that created date time or create date time, this is created whenever the event is actually created, so aka happen, and the time is in UTC. So in this example, it's 4:37 UTC, 30 seconds. Meanwhile, the NQ time, this is when the sign-in is being completely done after being processed by the like risky sign-in model, and then and it will be local time, and the time that we are having, it's in the EST or EDT, which is 4 hours ahead. And then if you can see, there's actually 4 minutes delay because it's on the minute 37 when it's created, and it's on the minute 41 when it is completed processed by Microsoft machine learning model. So more other stuff from the sign-ins will tell you about MFA and conditional access stuff. For example, the first screenshot on the top left, it is conditional access policy. So which conditional access policy apply for this particular sign-ins? It will tell you if it passed it or not. And then conditional access policy is actually only available for certain Azure AD licenses, so you need to pay attention to that. Now you get authentication details, which tell you is it single factor, multi-factor, which model of authentication that they are using. Could be as simple as pass-through authentication, PTA, or they're using the hash synchronization, or is it using for the MFA, is using the Azure AD app, or etc. And lastly, we get like the conditional access status, such as like failure, like the authentication, information such as multi-factor, single factor, which you can actually take from the previous few, you know, like information or like attributes. So lastly that we're gonna talk about, it's gonna be the risky sign-in. Not lastly, actually, there's some more stuff, but risky sign-in is the one related to the sign-ins one. So you'll have risk information on it, such as like, is it at risk or not? You know, which is pretty straightforward. The level, which is, as I mentioned, low. It's only available for the P2 licenses, and then on top of that, it will tell you like which event types. So we're gonna talk about the risky event types in the next slide. Yeah, as I mentioned, the risky will take some time to load. It could be from 2 hours to 24 hours. So there are different, you know, risky sign-in event types. There are I try to categorize it based on the, you know, like bigger types. So you get location-based risk, you get IP address-based risk, anomaly-based risk, and some other risks, such as for the location, you get atypical travel, impossible travel, new country. So this is pretty much if a sign-in is coming from unusual location, pretty much. And then IP address based, so this is being enriched with threat intel information, such as, is it malicious IP address, is this anonymous, we're talking VPN, Tor. Again, malware link IP address related to the first one, malicious IP address, and activity anonymous IP address is actually related to the second one. Anomaly based risks, we're talking about anomalous token, or like token Azure anomaly. So for example, a new identity provider being introduced that can cause this you know, anomaly. Suspicious browser, other sign-in properties, user agent, application, etc. So it's comparing the logged in of the sign-in of this user with the historical data that they have, and then from there the machine learning model decide is it suspicious or not. And then if they do something on the Office 365 related stuff, it can tell you if it's suspicious or not. Some other risks, try and tell, you know, like the admin can actually confirm if the user compromise. Password spray, I think that's a good one to have. And an additional risk detected, which is can be anything based on the risk model that Microsoft is, you know, providing. For the audit logs, we don't have much here. Pretty straightforward. So you can manage user, you can manage group, you can manage application, you can manage role. There's more management, you know, types in there, but this is the common four. So such as creating new user, you restoring group password, you're getting policies for the group, you set up MFA on certain application, you're issuing token or authentication code for the user. And for the role management, you can add device, remove user to device on that particular role. Again, conditional policies for the particular role. So it's pretty straightforward. The lists are provided in the Microsoft website, so if you want to know more. But yeah, so that's for the audit logs. Now let's move forward, and you know, let's play a bit more with the Azure AD reports now. So let's do threat hunting with it. So prerequisite. So you need to understand your organization first before you try to do threat hunting in it. You're required to have mature security and compliance policies also. So you need to know, for like things like, where are my employees? Do I have contractors? My subsidiaries, my vendors? And then, are those contractors are using VPN technologies to log into our system? Are they using proxy? So do we use other, you know, application in the cloud? Or even just, can regular user use VPN? Like, you know, I'm talking about NordVPN, like, you know, like all those VPN, is it against our policy? Again, back to mature security and compliance policy. Can they use it, right? And can user bring their own device, or are we provisioning our own devices? So if you're, for example, for this one, if you're seeing a new device that is not, you know, yours, so that's definitely something questionable happening. And then those policy, you can actually translate them to conditional access policy in Azure. And it will actually add extra layer because your policy it's now actionable items by Azure AD security. So you need to understand Azure AD security operations. So like when something suspicious, malicious happen, like what am I gonna do? Can I revoke their session? How do I change user password? Or how do I enable MFA for users? So things like that you need to understand first. It could be you, it could be your additional managed security provider or etc. It will be great if you can understand the attack concept or even just Azure AD concept in general, like how SAML, all out, you enter cloud lingo here, work. What about ADFS? Like half cloud, half on premise. So if you understand that information, you're definitely able to do threat hunts. And of course, you need access to Azure AD to get those logs, Azure AD reports. And SIEM is actually recommended because it gives you better visibility, actually give you better functionality such as aggregation. You can start visualization. You can create easy statistic just by doing that. So it's really recommended. So attacks that can be detected via Azure AD reports. So we got attacks on the left side and then some additional stuff that might interest you on the right side. Password spray, 230% increase. You want to try to detect that specifically legacy application and single factor account. Brute force, multiple brute force on a single factor account. MFA brute force, so they just spam users with MFA requests until they approve it, and then you can get combination of them. And then you get username recon, and then lastly, compromised account. So credentials get phished, credentials get leaked, companies get breached, credential being reused by your user. So yeah, compromised password, compromised MFA, which is like user approving MFA pretty much, which I tell like really funny, really stupid, but it happens. Not once, a lot of times. So yeah, breaking news. Password reuse leads to account compromise. Yes, I'm actually been a victim to that. So I reuse password. I know, security person doing not security stuff, but yeah, I reuse password in one of my account and it got compromised, and the attacker used credit card, blah blah blah, and then I learned from that actually. So yeah, I'm trying to bring that to here also. On top of that, on top of attacks, you can actually detect unusual suspicious signals such as single factor in the MFA environment. Why there's a single factor when my policy it's MFA, so you can actually investigate that. Malicious IP address trying to connect to my network. Why is that? What about the sibling IP address? I'm talking about the same ASN, same subnet. Suspicious ASN, Tor exit node in my network, VPN, VPS. When our policy say we don't need it, we're not allowing it. Data center hosting trying to bombard our network. So you can find all the answers there, and then you can decide if it's malicious or not. Suspicious application. Why are we seeing legacy application although we already blocked them? So it could be potentially can be an attack or something like shadow IT. You just don't know it's there. Suspicious user agent. Sometimes you'll see things like scanner. Sometimes you can see legacy user agent that's being actively exploited. That's just I'll take the example back to AeroPC, which is the Exchange Active Sync, actively, funnily speaking, actively being used to obtain credentials using password spray. And then unusual user agent, you just need to answer the question why it is there. So you can look for all this information using this logging system. And then let's talk about what type of attacks that can be detected. So for the password spray detection, a logic is you're saying high number failed single factor, there's some success, unusual IPs. So normally you correlate it by IPs, but you can also correlate it by user agent. You can correlate it by the application they're being targeted, which is sometimes really being used by your users. So you can use that, and then you can sometimes you'll have multiple users being attacked. most of the times, I would say. You get legacy and single factor application being used because they try to downgrade your MFA to single factor. So yeah, for the password brute force, the difference will be like that application might not be legacy or single factor. So they maybe they don't know that you have MFA, and then from there they actually just keep trying, and then they find MFA and they'll do the MFA brute force, which is the next one. On top of that, the above one, you'll have single factor success, high number of fail MFA, which is really funny because when that happens, I think the user will probably aware of it, but sometimes they just get better, they click it, and then the attacker get in. Normally they'll use the mobile app notification or phone call because it's more annoying compared to text. You get unusual IPs, very likely hosting, and we're talking about AWS, OVH, it could be also DigitalOcean IP address. And then you'll see unusual user agent, could be like Microsoft Office, like some other stuff also, and then it could be single or multiple users. So here you can see also like error codes that you might want to watch for these scenarios. And then for the response, what you want to do when you're being attacked, you need to make sure you collect all the attacker IP address. So you try to collect all of them. Maybe it's a sibling IP address like ASN based on, or they're from the same subnets. You want to look for error code 0 firstly, because you need to make sure that that IP address is none of them are successfully logged in. You can actually check on your Office 365 logs for authentication logs just to make sure, double check it once you have all the IP addresses. If any success for single factor, so it means password compromise. So you need to review audit logs, you need to review Office 365 logs and see what's going on with the user, what are they doing inside after they're successfully logged in. And then while doing that, you need to revoke session, you need to reset user password, enable MFA when possible. If the successful a compromised account was actually multi-factor, again, reviewing the logs, that's important. You need to reset password, you need to add new MFA deface, and then sometimes attacker will make changes and you need to undo all of that, including the one that I saw quite often is they're replacing the MFA devices with their own devices, so they locked up the users. So you need to make sure you take that out and bring the user's MFA, or even you can lock out the account until the users are ready to do the MFA process. And then you can block it, the IP addresses, or you can report it to the authority. For the less frequent attack, less volume, such as compromised password and MFA, and then a recon, you'll see majority will be successful, like single factor, could be in the middle of brute force or password spray. The IP address will normally coming from like hosting, VPN, Tor. You will see like unusual user agent or devices. You can correlate it using that, and then you'll see multiple users or maybe even single users if it's just out of the like normality for that particular user. So this is unusual for the users. So this is what you want to do when you're seeing that. For the username recon, you'll probably see a lot more invalid username or password, which in this case will be username. And then what you're going to do for the response is pretty much the same. Collect the attacker IP address, look for error code 0 for success because you don't want that. Again, review logs, revoke session when needed, and you need to make sure that you enable MFA when possible. If the attacker makes some changes into your environment, you need to make sure that you actually undo their changes. All right, as I mentioned before, you can report them, block according to your company policy. Sometimes when it's not possible, you want to track them, so you can add them to your threat intel platform. Could be MISP, could be some other threat intel platform. So yeah, the problem with this hunt, uh, you'll see a lot of data, especially when you're a large company, multinational company. Threat hunting is not it will be hard. Based on the experience that I have working in the several big organization, like false positive will occur on the different Azure event types. So for the location base, right, a typical travel, impossible travel, new country, your employee will travel eventually, could be from business travel, could be from vacation, external consultant on VPN, especially in this pandemic era, like people working from home, they need to use VPN sometimes to connect, sometimes they go to different country, meet their family, and they work from there. So you need to take that into consideration. A malicious IP address or a malicious malware link IP address, it could be stale threat intel. We're talking these days, like threat intel, I don't know, it wouldn't last for like few weeks. It's become stale because everything is on the hosting, right? So those information might be wrong, and then maybe they just share like common IP address. Maybe one of the user, for example, within the telco network got compromised, but it's not your user, but they are sharing that one IP address. So for anonymous IP address activities, so VPN is being used normally these days for the users. It's up to you, are they allowed to use it for work or not. Sometimes they just forget, they logged in from their mobile devices and the VPN is on because they watch Netflix like from Canada in the US. So it could happen all the time. Suspicious browser and firmware sign-in properties, this can happen when they're using VPN. This can happen when they are like just being different for once, visiting family, they borrow their laptop, I want to check my email, can I borrow your laptop, or they have a new phone. False positive everywhere. So in order to approach this, you can actually approaching it on the tier level. So you go for the high one first. Once you get familiar with that, you can go to the medium, to the low. Eventually you can actually take all the data and like not the risky sign-ins data, maybe more than that, all of the data, all the sign-ins data, and you start processing it yourself. You might find more stuff, but of course it requires resources and talents to do that. Moving forward, how do we reduce the false positive ? Great question, right? So sometimes once you baseline your user, you can actually know like which telco company is where my user coming from. Please note, like having a list of known, having a list of like benign something, there will be like a blind spot. So is this an acceptable blind spot for you? For example, is it vendor? Is it consultant? What if the vendor get breached? I mean, it's probably a really like small percentage, but are you comfortable with that risk? You get a list of known VPN and Tor user. Sometimes the security people need to use Tor, so you might want to whitelist that, or like allow that connection. List of known country or city. Sometimes you'll have people traveling, and then those country within like you have offices in those country, and then that should be fine. If your company having business or like have offices in China, for example, it's okay. Like it's not attacker, because sometimes some people have business travel to China. Could be you can have a list of user with legacy application, single factor authentication application. So here you will that's the thing, like you need to have this knowledge first before applying this reduction, right? You can have a list of approved application, device type, user agent. So anything on top of that, it's you would say 99% malicious because it's not approved, or at least they breach the policy. So this is still something you want to see. And lastly, maybe not maybe, you should always compare user behavior with their past behavior using the Azure sign-in logs. So you can actually, if you put it in your SIEM, you can actually have, like data all the way back to 30 days, 90 days, and you can easily compare them. You can search them by IP address, you can search them by, like user principal name, etc. So these are ways to reduce false positive. So introducing Azula. Yes, the lady on the side is Azula from the Avatar The Last Airbender TV show. And yeah, disclaimer first, this tool is still in development. I'm working on it really slowly. The one that I have right now, it's not great, it's not optimized, so I don't want to release it. So I will be releasing it as a POC. Modification is 100% required for this for operational use, because I'm not gonna share what we are seeing in our environment, because first thing first, it's our stuff, legality, privacy, etc. And the second thing, it will not work with your environment, because there's no one environment is the same in the world. So those are just disclaimer. So Azula, when almost is not good enough. So we get everything here. We get attack detection, response pattern. We get threat hunting at scale. We know the problem. We know what we need to watch. We know ways to reduce false positive. So all of that is great, but it will still take a lot of time to do. Based on experience, it takes hours and hours to process data. I mean, we do process a lot of users, but I believe you will also be processing a lot of users. So it is almost perfect until Azula. So Azula is Azure AD unified, lightweight, automated. You can see how I tried to push it, but I make it work. So it's a Python-based automation with some data analytics and historical reference systems. So comparison, in short. So it relies mainly on the sign-ins and risky sign-ins reports. Audit logs and some other logs will be used for investigation easily. There's 5 main components. OSINT enrichment. As I mentioned, we like to compare it with other OSINT sources. So check the GUIP, ASN, check if it's a VPN, Tor data center. On top of that, later there's some improvement that you can do. I'll share it with you. We got the logic engine, which is it will help you to process the data. For example, if you have North American contractor, for example in Mexico, in Canada, and your company is in the US, you might want to start in a sense suppressing the invalid risky sign-ins from that. So if they're using VPN in a location based in North America and specific account, maybe they start with prefix CONTR for contractors. So scanner success logged in. So if you see scanner in the last you observe brute force, for example, last 30 days, and then you store it in your MISP, and that if this particular IP coming in successfully logged in, error code 0, you want to know that. so that's some sample scenarios that you can have. Of course, you need to tailor it to up to you. This is why this tool is not. You need to configure it first, in a sense. We get 2 reference DB, known and bad. So, for example, if you have benign ASN, if you have vendor ASN, known VPN or Tor user, you can add it to this file, and then you can work on the logic engine side. Bad user agent, suspicious ASN, legacy user agents, legacy applications. So this is just letting you know, for example, some legacy applications are being used and your policy, for example, is not allowing that. So, and lastly, we get reports input-output engine. So this is just processing. So we're actually using CSV files because it's fairly easy to get report as a CSV. This day, I think most of the tools, SIM, even the Microsoft tools, are actually providing CSV files. So from there, you'll get the data required, and then you put it into the input, and then you'll get a comment with some enrichment into the file after it's being enriched by Azula. So yeah, Azula step by step. If I try to break down what it does, so you prepare the CSV with the right information. The Azula will transform the data CSV to pandas, modern big data stuff. Will enrich IP address information. It will apply the logic that you have decided, you have coded. We'll compare it with the reference DB, bad and known, of course, depending on the logic. And we'll add the commands and add the enrichment. And the analysts, threat hunters will review it and complete the result. So this is definitely will bring down the works of the human on this side. So some screenshots. So the logic. So for example, we get the suspicious user agent. We get phone application. So we know this is our common application from phone. You get, for example, suspicious user agent being used. So this is the logic, the middle one there. We get B9 telco for example, people in Canada, people in India for our consultant, people in US for our contractors consultant. So yeah, so these tools will also enrich the IP address. So this is the form of enriched IP address. So we get the IP, we get, is it data center, is it VPN, is it Tor, we get location, city, we get the ASN, and we get host name when it found, of course. So yeah, pretty much the Azula will turn the one on the top. So all this information are coming from the Azure risky sign-in, also sign-in reports, and then on the after processing you'll get IP info, because this is our the enrichment that we do from IP info, spur.us to let you know, is it is it hosting, is it data center, is it VPN, is it a Tor, and then from there all the logics processing, you will provide you with some comments. Sometimes it will be empty because there's no logic that apply to that. So those are the stuff that you need to focus on. You can actually see some suspicious stuff from legacy application, the last few lines. So it's being flagged saying this is possibly brute force. As you can note on the count on the very right side, bottom right, it's pretty high. So this is why the application telling this is actually brute force. Demonstration, just like demonstrating Azula fighting versus Aang. So yeah, let's play the video. I'm just gonna grab my mouse. So as you can see, this is the Excel, and all the information, as I mentioned, is provided by your Azure AD reports, and then from there we are recording information such as username, IP address, user agent, application access, error code, failure reason, just for better for our eyes, risk reason, and then count. So what gonna happen? So yeah, we just close that. We put it in the folder that where wherever the Azula script will read it. Mainly it's now in the download folder. So if you put the reference file, the input there, it will read it from there directly, because we use Elastic and Kibana save CSV directly to download folder. We just practicality pretty much. So some ASCII art, and then enrichment, reading from CSV done. We'll see, tell you how many IP addresses they are sending, unique also, and then enrichment. For some reason I forget to scroll down on the console. So I'm running it on PyCharm. You can run it using console. You can apply it to your automated solution right away. It's just a piece of code. Yeah, and then from there it will tell you, okay, you have this file that you need to open, and it's already enriched, and I'm opening that file now there. So yeah, so we are almost there. As you can see, IP info is being enriched. There's some encoding problems with extra characters, so that's something that you want to play around as an improvement. But it'll tell you city, which ASN, and then hostname when it found, and then spur US will tell you pretty much, is it data center, is it VPN, and it will comment it. As you can see, it comment most of everything, but there is benign one that we already see. We know based from our experience, from historical data, that user from certain ISP, from certain location, it's normally contractors or consultant. And we get, like some phone observe. And then we get benign stuff also. So we get, for example, mobile application being used, which is Outlook Mobile, which is line 4 from phone. And then we get some bad one on the bottom. We can actually detect it's possibly an attack because it's coming from similar IP addresses trying to access different account and trying to combination, creating a lot of error messages using like suspicious user agent, which is the Microsoft Active Sync. And yeah, so based on the account also. So this is our the demo of the Azula. So I'm gonna move to the next slide and we're gonna go to some closing remarks. Blind spots. So Azure risk model, it's great, but of course it can miss some of the attacks. So it's always a good idea to review all sign-in logs when you can. Don't try to push it right away. Don't try to, okay, I'm gonna review all the sign-in logs. I'm telling you, there's like millions, if not billions of them coming in, all the time. So set your priority rights. The model is really great, but it can miss something. Make sure you keep that in mind. Threat intel information can be misleading sometimes, even if you compare it from different sources, because sometimes they just pull it from one real sources. So yeah, stale intel, accidentally added intel, so it could happen. So make sure that you're aware of that. You can actually confirm with the user if you're questioning some of the like IP address being you're seeing on your environment. So creating a known list or like allow list, I would say, based on signals, it will create a blind spots. So you need to treat it carefully. So I'm talking about what approving or like making a known list based on the ASN, based on IP address block, based on like certain applications. So there will be blind spot. Treat carefully and make sure before you do it you need to accept the risk and you understand that the risk is there. Improvement ideas. So we get correlation with historical data, so live stream of data using SIM API. So you can use it with Elastic, you can use it with Splunk, some other stuff. You can actually do additional enrichment. So you remember that when their error code contains others, you need actually to look up for it. I actually have a prototype the code that actually scrape the Microsoft page and it's just automatically pull the data based on the error code. Unfortunately I don't have it ready yet, but it's an idea there. IP abuse database, this is known scanner, gray noise. Maybe you can even enrich your user with the HR system, so you can pull their location, you can pull where their office is, you can pull like which time zone they're working. So if you see some login in a weird time, then okay, this is probably not the user, it's probably someone else. You can connect loggings from different sources, audit logs from the Azure AD logs and Auth365 logs. You can actually log them, use those logs and compare it with the situation before, what changes they made after a compromise. You can actually use proper database instead of TXT file, like what I'm doing here. You can use MongoDB, JSON base, or you can use SQL. It's up to you. We are building something like that in production for us, and we're using MongoDB. So TXT file, it's great for now, but once you scale it, it's probably not gonna be great in terms of like input-output processing. So thank you so much, everyone. If my time is not wrong, I think we are having pretty good time here, and there's still time for question. You go to the Discord and ask questions, and I'll be there, or you can contact me on like Twitter, LinkedIn. My information is available on the Texas Cyber Summit page. Thank you so much, everyone. I hope you have a great time here. I hope you have a great day. Thank you.